let's find and interpret percentiles of a data set. So first, what is a percentile? Well, it's the percentage of values at or below a particular data value. So if we say what number is the 70th percentile, well, we would find it in, we'd find the value. So if we say 70th percentile, that means all of the numbers in front, there's 70% of the numbers in front. An ordinal rank, just to be an idea here, the location of a particular value when ordered least to greatest. So you would say like the ordinal rank is 12th. That tells you the location of the value. Okay, to find a percentile, we use the formula R equals P over 100 times the quantity N plus 1, where R is the ordinal rank, right, what position we're talking about, P is the percentile, N is the total number of data values. If R is a whole number, that's the position. So if it says 12, it's the 12th number. If R is a decimal, which is probably more likely, the percentile is the average of the two positions on either side. So if it was 12.1, we would find the average of the 12th and 13th positions. Now you can imagine if you have a data set that's like 600 numbers long, this could be very tedious. But for our sake, we're using smallish number sets. So we have the number set 2, 6, 9, 12, 14, 14, 18, 22, 24, 31, 32, 34, 40, and 41. So we're trying to find the 70th percentile. Okay, what do we know? Well, if I add up all my numbers, there's 14 of them. So N is 14. And I want to find the 70th percentile. So P is 70. Therefore, I can find my ordinal rank, right? Which number falls in that 70th percentile. So I use the formula R equals P over 100 times the quantity N plus 1. And I plug in what I know. So 70 over 100 times 14 plus 1. Well, 14 plus 1 is 15. So we can do that. And you can either type this into your calculator exactly like you see it. 70 divided by 100 times 15. Boom, one spot and you're done. Or you can do 70 divided by 100, which gives you 0.7, and then multiply by 15. Either way, you get the answer of 10.5. So that means the average of numbers of positions, of positions 10 and 11, right? These are the positions. That is what will be my 70th percentile. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the 10th and 11th are 31 and 32. So I add those together and I get 63, take the average, so I divide by 2, and I get 31.5. So 31.5 is the 70th percentile. That means 70% of our data is at or below 31.5. That's what that means. Let's do one more. Find the value of the 15th percentile. Now, one thing I do want to say also, we know 70th percentile is more than half, right? 50% is our halfway point. So we know that it should be to the right, on the right half. Whereas 15% is way less than half. So it's going to be somewhere over here, right? So use like a little bit of common sense when you're like, where's the general direction of this? Okay, so let's figure this out again. What do I know? Well, here I have 13 numbers. So N equals 13. 15th percentile, so P is 15. And once again, I plug it into my formula. So R equals P over 100 times N plus 1. Let's plug in our stuff. So P is 15, N is 13. Let's simplify. 15 over 100 times 14. And once again, you can type this in exactly like you see it. 15 divided by 100 times 14. And this is going to give you a value of 2.1. So that means we are looking for the average of positions 2 and 3. All right, well, let's find those. 2 and 3, so it's not 1, it's 2 and 3. So the average of 12 and 19, so I get 31 divided by 2 is 15.5. So the 15th percentile is 15.5. Whoop. Messed up my decimal there. 15.5. So that means 15% of my data is less than or at 15.5.